So let's talk about the brickwork and let's talk about the actual sizes of the brick, because what we're actually doing is creating this cavity wall made up of 2 bricks. What are those brick sizes? Typically, I'm talking about metric bricks here, on below ground engineering bricks. They are going to be 100 millimeters wide. I know they're 102 millimeters, but really made simple, we're talking about 102 millimeters wide. This is no joints on this. We're talking about a cavity, which is a gap of 150 millimeters, and then we're talking about another engineering brick to the inner skin of 100 mil wide again. So overall, you have a nominal cavity of 350 millimeters. Now, again, the principles of why we're making them those sizes is because of the fact that we're improving the insulation of the building, and this is the new Part L regulations of the building approved documents. Admittedly, there are different ways you could make up a wall with a cavity, or to try and meet the U value. The what? Yes, the U value. We will talk about that later on, but we're talking about the calculations and the science behind the heat transfer or the heat loss. When we put on our jacket that's heavily insulated, we lose less heat from our body. With buildings, there's a calculation of how you prove what that's worth, and the building control, the building approved documents sets out the criteria. Yes, somebody's actually sat down and worked it out, what that needs to be, so you are not losing heat from your building. And I have to say, buildings these days are incredibly warm and incredibly efficient, a lot more efficient than older property buildings. The principles around the cavity, whether it's above ground or below ground, are the same. What it does, it allows water to penetrate the first layer, and only the first layer, and any moisture and water that's in there will run down the cavity. It also allows the cavity to contain insulation, and the insulation adds to the thermal value of the house. We all know if we put a warm coat on, or a coat that's really thick and woolly, it gives us a nice cozy feeling, because basically it stops the warmness within us from going to the outside air, which would make us feel cold. And it's the same principle when we wrap a house with insulation. That's why we put insulation in the floor and in the walls and in the roofs. It is proven these days that we lose a lot of energy through the floors. That's why we put insulation in the floors. But let's talk about the walls. So when I show you these diagrams of the brickwork, of the foundations, effectively what I'm doing is I'm actually creating a slice. So I'm slicing through the area that I want to depict, or at least draw and show you. That slice is called a section. So on drawings, when you look at things, people refer to elements of work as a section through this or section through that, but effectively, or essentially what we're doing is just taking a slice through it. This element is your internal skin, and this element is your external skin. It's a cavity wall. Cavity walls are something that were introduced, I believe, in around the late 1960s. Before that, most house construction was made of solid brick, and I am going to talk about brickwork in another video, and we have a massive traditional or elderly housing stock, which we're all trying to improve, fix, extend, and the impact of what I'm talking about today does relate to that, and it has we have to take that into consideration when we are trying to extend. But I'm talking about what we have to do when we extend buildings today is bring them up to 2024 standards, when this video is actually being made now, and we have regulations with regards to carbon emissions and net zero that the building regulations are trying to drive. The government is pushing that, and the legislation around the building regulations affects that, hence why the cavities have now increased. We are looking at a minimum of a 350 millimetre cavity wall now, and basically that's going to be made up of 100 millimetre brickwork to the outside nominally. We will talk about the brick in a minute because it's actually 102mm metric bricks, but there are tolerances around that because essentially it's clay, it's baked in an oven. So, but I think that we have to get to some kind of measurement. So as I say, building made simple, let's call it 102mm brickwork. So that is the width of the brick. So what do I mean by a course of bricks? Let's go back to the sketch. When I do the sketch and I draw a brick, I'm drawing a brick like this and I'm laying another brick on top of another brick. So going back to our dimensions that we talked about previously, what we're saying is that a new brick is 65mm high, but with the course, that makes it 75. So you always calculate your courses with a 10mm mortar joint. And the mortar joint is the sand and cement and water mix. And that's mortar. When it's shown in a slice, the architectural way of showing brickwork in a slice is to put two lines across like 45 degrees. And that depicts, or that shows that it's brickwork. If you use blockwork, which also, by the way, coordinates with brick, that's shown as a single line. Blocks are designed to match brickwork perfectly. They are 100mm wide, 440mm long, and 215mm high. So when you add the joints, they coordinate and correspond exactly with the brickwork, which is a really cool thing.